Planet Venus has retrograde rotation. This is certainly no coincidence, as has been believed so far. As said, in order for a body to be able to rotate in the gravitational field of another body, it needs its own rotational force, the strength of which is greater than 2/pi times this gravitational field. Venus is in the Sun's gravitational field with a strength of Gs equals 11.310 to the power of -3. To overcome this, one needs a rotational force of However, Venus only has a rotational force of 4.810 to the power of -3, which is equal to the primordial force of the solar system. Thus, it would not have been able to rotate in the Sun's gravitational field. In this situation, if Venus has walked from point A to point B, her face to the Sun remains unchanged. And it is practically pinched and dragged along by the Sun's gravitational field. Then it would be a bound rotation like the Moon around the Earth. Their rotation would be prograde. In reality, however, Venus oddly rotates retrogradely. But why? When a satellite has no spin of its own, it is in a state of rotational weightlessness, vulnerable to the gravitational field. In such a situation it will be able to be turned by a small force acting in a tangential direction. Because the gravitational fields on the sun-facing and remote sides of Venus are not equally strong, a spinning effect occurs. This is exactly what caused the backward rotation of Venus. So the gravitational field of the Sun at point A is greater than at point B. Therefore, the orbital speed around the Sun is greater at point A than at point B. This creates a clockwise rotation. The orbital speeds around the Sun at points A, O and B are as follows. This results in the rotation speed of Venus with For comparison, the rotation speed of Venus is actually about -1.8 m/s. This result assumes that the orbit of Venus would be a round circle. This backward movement of Venus resembles a differential gear, a mechanism often used in the automotive and mechanical engineering industries. It is quite astonishing that such a fine mechanism is used in nature. This rotation speed of 1.95 m/s, which we calculated, is under the assumption that the orbit of Venus would be a circular orbit. With this speed of rotation, Venus rotated once in the time it took to complete one lap around the Sun. Of course, that's no coincidence either. Suppose the angular velocity of Venus around the Sun is omega r. And the rotational angular velocity omega r is It behaves as follows. So omega r equals omega r and theta equals theta a plus theta b. This means that if the orbit of Venus were circular, Venus would have rotated once in the time it took to complete one lap around the Sun. But this is not a bound rotation like the Moon around the Earth is in the case. As I said, this result assumes that the orbit of Venus would be a round circle. In reality, however, it is not quite round. In the next video why Mercury rotates differently than Venus, we will learn how a non-rounded orbit can affect its rotational movement. Thank you very much for your attention. See you next time.